Good morning everybody. In this video, we shall discuss about the loss of kinetic energy due to direct impact of two smooth spheres. Let m1 and m2 be the mass of the spheres. That is, m1 denotes the mass of the first sphere and m2 denotes the mass of the second sphere. u1 and u2, v1 and v2 be the velocities before and after impact. That is, u1 denotes the initial velocity before impact and u2 denotes the initial velocity after impact, whereas v1 denotes the final velocity before impact and v2 denotes the final velocity after impact. E is nothing but coefficient of restitution. By Newton's law, we are arriving the result v2 minus v1 equal to minus E into u2 minus u1. But by the principle of conservation of momentum, we came to know that m1 v1 plus m2 v2 equal to m1 u1 plus m2 u2. Total kinetic energy before impact, that is, the formula for kinetic energy is generally half mv square. Here we are having two kinds of velocities. So, total kinetic energy before impact equal to half m1 u1 square plus half m2 u2 square. That is, we are clubbing the mass and the velocities of initial, final and the two sphere also. So we have to add them. Total kinetic energy after impact equal to half m1 v1 square plus half m2 v2 square. Change in kinetic energy is nothing but initial kinetic energy minus final kinetic energy. So initial kinetic energy is nothing but half m1 u1 square plus half m2 u2 square minus final k dot e is nothing but half m1 v1 square plus half m2 v2 square. And since it is the mere addition of four terms, we can club the first and third term. That is, we can change as we need. Half m1 u1 square minus half m1 v1 square, and second and fourth term as together, plus half m2 u2 square minus half m2 v2 square. So the half in the first two terms we can take half m1 as common. So inside the bracket we have u1 square minus v1 square. In the second two terms we can take half m2 outside. So inside the bracket we get u2 square minus v2 square. So u1 square minus v1 square is of the form a square minus b square. So it can be written as u1 plus v1 into u1 minus v1. And similarly for the u2 square minus v2 square we can apply the formula. So next step is half m1 into u1 plus v1 into u1 minus v1 plus half m2 into u2 minus v2 we are bringing front and keeping the u2 plus v2 next. So we can expand them. In the half m2 into u2 minus v2 can be written as half m2 u2 minus m2 v2. But by the using the second result, we are having m1 v1 plus m2 v2 equal to m1 u1 plus m2 u2. So applying that result, m2 v u2 minus m2 v2 can be written as m1 into v1 minus u1. So again in the same in the half m1 into v1 minus u1 we can take half m1, after that minus outside. So inside we get u1 minus v1. And totally for the four terms, now I am taking half m1 into u1 minus v1 outside for the four terms also. So inside the bracket I have u1 plus v1 minus u2 minus v2. And again I am clubbing the first and third term, that is u1 minus u2 plus v1 minus v2. But v1 minus v2 by coefficient of restitution, we have v2 minus v1 equal to minus e into u2 minus u1. So we can instead of V1 minus V2, we can write plus E into U2 minus U1. And again I am taking that plus E, I am taking minus E outside. So inside the bracket I will get U1 minus U2. So by the method of factorization, we can write since U1 and U2 are both are same, we can write U1 minus U2 into 1 minus E. But from second result, we have M1 into U1 minus V1 equal to M2 into V2 minus U2. On rearranging and bringing the M2 to the left side, we have U1 minus V1 by M2 equal to V2 minus U2 by M1. And by the fraction rule, and each is equal to U1 minus V1 plus V2 minus U2 by M1 plus M2. And we are adding again U1 minus U2 and V2 minus V1. We are changing the terms. So that is equal, instead of V2 minus U1, we can write minus E into U2 minus U1. Again we can minus E, we can, when we change into plus E inside the bracket, you will get U1 minus U2. By the method of factorization, we have the numerator U1 minus U2 into 1 plus E divided by M1 plus M2. And therefore U1 minus U1 can be written as M2 into U1 minus U2 into 1 plus E by M1 plus M2. Substituting the fourth result in third we are having here, that is change in KE. That change in KE, we have that I have named that third. So we have to substitute the lastly arrived fourth equation in third. We will get change in KE. That is we have to substitute the expression for U1 minus V1. I will get generally half M1 M2 by M1 plus M2 into U1 minus U2 the whole square into 1 minus E square, because 1 plus E into 1 minus E can be written as 1 minus E square, and U1 minus U2 and into U1 minus U2 can be written as U1 minus U2 whole square. So final result is half M1 M2 by M1 plus M2 into U1 minus U2 the whole square into 1 minus E square. That's all. Thanking you.